In this video lesson, we're going to learn about alcohols and ethers. So alcohols have a functional group of OH, which is the hydroxyl group, and alcohols are liquid at room temperature, and they're soluble in water and other polar substances. But as the number of carbons increase, the solubility of the molecule will decrease. To name an alcohol, you count the number of carbons in the parent chain, and that would be the longest chain that has a hydroxyl group in it. And you name the molecule like an alkane, but you drop the E at the end and add OL. And you need to number the position of the OH group from the end closest to the functional group if necessary. So here's our first example. We have 3 carbons, so 1, 2, 3. So the alkane would be propane, so we drop the E and add OL, so it's propanol. And the hydroxyl group is on the end carbon, not on the middle, so it's going to be 1 propanol. Now when I numbered this chain, I should have numbered from the end closest to the hydroxyl group, which is why I said it was 1, not 3. So these numbers actually should not be here. So it should be 1 propanol, not 3. Now ethers have an oxygen bonded between 2 hydrocarbon chains, and they're actually more polar than hydrocarbons but less than alcohols. So if we take a look here, you can see the oxygen bonded in the middle. So to name an ether, you select the prefix for the shorter chain and add oxy to the end, and then you add the name of the longer alkane to the end of the first part. So you would name it exactly like an alkane. So here's our example. So in the shorter chain, which is at the right, there's 2 carbons. So that's going to be F-oxy. And then the second part has 3 carbons, so it's propane. So it's ethoxypropane. So now we'll practice with a few. So for this one, we can see the hydroxyl is closer to the left end. So it's 1, 2, 3, 4, 5, 6. So it's going to be hexanol. And the hydroxyl is on the 3rd carbon, so it's 3-hexanol. Our second one, we have the hydroxyl is at the other end. So there's 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be octanol. And the hydroxyl is on the first, so it's 1-octanol. Next one, we're being asked to draw 2-hexanol. So we're going to draw our parent chain, CH3. And we know that the hydroxyl is on this one, so we're going to put COH. And there'll be another H down here. And then CH2, CH2, that's 1, 2, 3, 4 so far, CH2, CH3. And then 1 for butanol, so 1-butanol, so it's going to be, I'm going to draw the hydroxyl at the other end. So CH3, CH2, CH2, and then sometimes we do the CH2OH, like so. So now we'll practice with some ethers. So the first one, there's just 1 carbon on either side of the oxygen. So this is going to be methoxymethane, like so. The next one, there's 1 carbon here and then 1, 2, 3. So this is going to be methoxy again, but propane. The third one, we're asked to draw ethoxyethane. So it's going to be CH3, CH2, O, CH2, CH3, like so. The next one we'll draw as the more expanded version, so methoxybutane, so we've got a carbon, an O, and then 1, 2, 3, 4. So you can draw them this way as well, so you fill in the hydrogens. like so. Either way is fine. Whichever way you find easier to draw, you can draw them that way.